Well, here we go. In problem 29, we're asked to discuss the behavior of a curve at the point when x is -4 and y is +3. If you're not sure what they mean by behavior of the curve, you look at the answer options, tell when it's increasing or decreasing, tell when it's concave up or concave down. And what we need to do is remember that for increasing, decreasing, we can look at the first derivative. And for concave up or concave down, we need to look at the second derivative. So we've got some work to do. Let's get started. I'm going to find the first and second derivative of this function, evaluate it at the point -4, 3, and then we'll make our determination. Let's do some implicit differentiation. X squared plus 2y squared equals 34. Well, the derivative of each term here with respect to x is what we're going to find. The derivative of x squared is 2x. The derivative of 2y squared is 4y dy dx. The derivative of 34 is 0. Now we'll get dy dx by itself. Let's see here. So we're going to subtract 2x and divide by 4y. And we can simplify. We can call this the opposite of x over 2y. Okay. Now, we didn't have to isolate dy dx, but, well, yeah, we kind of did. We could have done it later. But now we know what dy dx is. Let's keep that in mind. Now let's go and find the second derivative. Well, you can tell we're going to have to use the quotient rule. It's low d high, so low times the derivative of the high, the top part, low d high, -1, minus high, the opposite of x, d low. Well, the derivative of 2y is 2 dy dx, all over low squared, 2y quantity squared, low d high minus high d low, all over low squared, and go Mustangs go. All right. Now, there's a couple different ways we could look at this. One way is to say, well, look at this guy here. We got a dy dx. We can replace that with the opposite of x over 2y. That's certainly one option. Oops, too thin. There we go. So the second derivative of y with respect to x. Let's see. 2y times -1, let's call that -2y, minus a negative, we'll call that plus 2x, now times the opposite of x over 2y. Now wait a minute, we can do some simplifying here. First of all, times 2 divided by 2, take each other out, and then we can pull the negative out in front. So we can just call this minus, and then x times x is x squared over y. Okay, and that's all over 2 times y quantity squared. Okay, now, we typically don't like to leave a fraction inside of a fraction. If we were just finding the derivative, we would simplify this further, but we're going to be putting values of x and y in, so we can leave it like this for now. Let's come back here and evaluate our first derivative when xy equals -4, 3. So let's take a look here. If x is -4, we're going to have the opposite of -4 over 2 times y, 2 times 3. A negative times negative is positive, 4/6. 2/3. We don't care so much about the number as much as we say that the first derivative is positive here at the point -4, 3. So that means our function is increasing. Our function is increasing. So let's see. A is a possibility, B is a possibility, C is out, D is out, E is out. Okay. Now let's evaluate this second derivative. at the point negative 4, 3. Let's see, we're going to get the negative 2 times y, negative 2 times 3, minus x squared, negative 4 squared, over y, over 3, all over 2y, 2 times 3, quantity squared. Let's see, so we'll get negative 6, and then minus 16 thirds, all over 2 times 3 is 6, 6 squared is 36. And keep in mind, we don't really care so much about the number value, so I want to tell if we have positive or negative. Well, negative 6 minus 16 thirds is going to be negative something, and negative 34 thirds if you wanted to keep track. And 36 is positive, so negative over positive equals negative. So that means our second derivative is negative, telling us about the concavity. Our function is concave down. So let's see which remaining option has concave down as an answer. Oops, too far. Sorry about that mix-up. Looks like A is out, and the winner is B. Our function is increasing and concave down at the point negative 4, 3. Well, there you go. Thanks for watching the video, guys. Enjoy the rest of your work.